All right, so I guess there was a slight mishap with the video that I uploaded for pretty much everybody, including me, and the mishap is it doesn't exist. It, it's it's disappeared. So we're gonna do another one really quickly. My recording device doesn't like when I switch windows; it just stops for some reason. So you didn't get to see this open, but that's okay. What I did was I pulled up this E. I'm gonna remove it. I'll just give you, I showed you this last time, but it never hurts to have to see it again. So we're gonna go to Open, Read from File, and I'm just gonna use this E that I used last time, and we can play it. There we go. And cool, that's the sound. So what we're gonna do to look at Jitter and Shimmer, which interestingly, you have to be very careful when you say the two of those together, because the first time I recorded this video, I had to edit out. I misplaced the j and the sh sound, and that's a total. I mean, like Shitter and Jimmer is nothing. Anyway, so or it's something. So you want to go to View and Edit, and then you get this cool little box here. Then you need to highlight what you want to look at. Now, you can only really measure the jitter and the shimmer and the harmonics to noise ratio on longer sustained consonants. Longer sustained vowels. Really short vowels, it's kind of like a boop. Doesn't work very good. There's not enough samples to actually get an idea of what's going on there. Consonants have a lot of noise in them usually anyway. So to get a really good picture of what's going on with the voice, with the vocal folds and not the other speech effectors like the tongue and everything, we need vowel sounds. So this E that we have here is going to work really well. And I'm going to show you in a second another an actual word and how you're going to pull vowels out of there. But so right now we're going to select some portion of this E sound, and remember this is just E. Then what we're going to do is we're going to go to Pulses and Voice Report. And this is pretty much all you have to do. So there's a lot of stuff that you can get from here. So one, it shows you what your time selection was, just to make sure that you selected what you thought you did. It gives you the median pitch and the mean pitch. So the mean pitch, this is a crazy cool estimate. It's 127.0. I've got a very precise fundamental frequency, and I like that. It gives you the mean period, and now if you wanted to be a real nerd, you could get your calculator and you could type in 1 divided by point, we're looking at right here. Scientific notation right here, negative e to the negative 3, so we're going to move it over 3 places, 1, 2, 3, so it's 0.007. So 1 divided by 0.00787,417. Now this 5. This should come out to be 127, right? And it's pretty darn close, 126.9974315. So yeah, it rounds to 127.0. Great. And that's, I guess, just a good way. You don't need to check this every time because, Praat's doing the right thing. But this is just showing that we know that period is the inverse of frequency, and so it should work out that way, that if you take this information, you can find this information. Really, They only really need to give us one of those because we could figure it out ourselves. But, you know, not everybody is as sophisticated as you guys now are. All right. So here is jitter, shimmer, and harmonicity. Jitter, we've got 0.1%. That's pretty great. That's very low. And that's what we're looking for. The shimmer is a little different here. In fact, it seems like there's actually, kind of a lot of shimmer going on here. And that's kind of interesting. 3.18%. So, by the way, I guess I should say this, but when I do it, I always look at the local jitter right here, the top one. Some of these other ones use some other metrics, and algorithms to compute jitter, but the one that's computing jitter the way that we've been computing it is this local one here, 0.1%, and the local shimmer, 3.18, 3.2%. So you can go based off of those. And then harmonicity here. Remember, I told you in the math review that sometimes people do noise to harmonics ratio, and other times people do a harmonics to noise ratio. And here you have both of those. So for our class, we want to look at the harmonics to noise ratio. It needs to be above 20 for there not to be not be indicative of a pathology. And indeed, we've got 28 decibels. So it looks like I don't have pathology in my voice, which is great. I didn't think I did. So what you can see here, this is the Praat user's manual for the different kinds of shimmer that you're looking at. And some of them have thresholds. So here you can see that for the local shimmer, the threshold is 3.8%. Anything above that is going to have is indicative of some sort of pathology. This one down here, you're looking at 0.35 decibels. Anything above that is indicative of a pathology. Not all of them have a threshold, and that's okay too. And so that's another one of the reasons why I like to use local up here. Is just it's got a threshold value. It's used a little bit more commonly, and so I go based on this one. So here, the way that this is computing it, you want to look for something below 3.8. So now we can investigate my shimmer, and it's below 3.8. So it's still a little high. That's kind of interesting, but not indicative of pathology. And then this one, the local dB, needed to be about 0.3 something, and it's at 0.27. So no pathology here in jitter, shimmer, or harmonicity. Okay, let's take a look at, we'll get rid of these two. Let's take a look at the file that I'm going to give you for your homework. Actually, let's take a look at this file really quickly. This is from the 2 modules ago. Yeah, you know what? Let's not use that one. That's not a voice. Never mind. So I'm going to open up the file that I want you to use for homework this week. And we're going to go to view and edit. I want you to hear this. This is
Corona.
This is a woman saying corona. Everybody's pretty familiar with that by now. So what you want to do
Corona
is highlight. You want to highlight the vowel. And let's listen to this one more time.
Corona.
You'll see that where these dark bands are here, that is indicating that there's a vowel there. So here, this is where we have the k sound, and then we have the k right here. And then we're going to have our liquid R, karo, right here. We've got this dark band again, so that's indicating another vowel, karo, na, right there. And then you can see that these dark bands just kind of explode out of there, and then we have this na that trails off. So the dark bands are indicating where we have good vowels that we can analyze. I chose this on purpose. Well, actually, I had this made on purpose because I wanted to have really elongated vowels for you to be able to analyze. So what you want to do to be able to analyze this is you want to highlight a good portion of the vowel, that much. We've got that, and now we can go to pulses and voice report. And we're going to see the voice report just for that selection from 0.16 seconds to 0.49 seconds. We can see the mean pitch is 204, gives us the mean period, gives us the voicing. And down here somewhere, it gives us the jitter, shimmer, and harmonics to noise ratio. But I'm not going to show you what those are because I want you to tell me for each of these three vowels what are the jitter, shimmer, and harmonics to noise ratio. Do any of them indicate pathology? And then listening to the sound, do you think that there is a pathology, or what do you think might be another cause for a higher or lower harmonics to noise ratio? Okay, so you can find those in the same module that you're watching in. So this file is going to be up for you to take a look at. The E file is already up in the other module, but I'm going to put it up here so you can download it and follow along with us if you want. And then the questions are there, so you can just go in and answer them. And you can watch along with this and answer them while you're watching along if if it's helpful to watch and analyze your sound file at the same time. Okay. Oh, well, I guess I should show you Audacity. All right, so Audacity isn't going to be nearly as cool. You kind of have to manually do it. So let's take a look at the E. We'll just zoom in. And you just kind of, when you do it with Audacity, have to count like we've been doing in the knowledge checks. So here's the E, and it looks to me like it would go from about here, not to here, but rather to here. And down here we get our length of selection is 0.139 seconds, and you would just have to kind of count these out. So there's one is 0.139, here's 2 is 0.147, 3 is 0.155, 4 is 0.163. So you get the idea. I'm just counting them out, and then I'm going to have to do the math by hand. You can also, there we go. If you pull down on this, you can also estimate the amplitudes. It doesn't look like there's a lot of shimmer going on here at all, which is great. So you can estimate these amplitudes, and then you will compute the jitter and shimmer values, just like we've been doing in the knowledge checks. Obviously, Praat is very much easier. I would use Praat for this for sure. If you want to visualize the spectrogram, I like Audacity, so I have both. And like I said, I'm trying to figure out what's going on with Wave Surfer. That one's a lot easier if you don't, if you're not very tech savvy. But I mean, that's kind of an oxymoronic statement because it's giving me a lot of tech problems trying to download it and getting to work. So hopefully, once I figure it out, you don't have those same problems. Anyway, for this assignment, I recommend Praat. But if you would rather calculate this by hand, you can. I would recommend that you take at least 10 cycles to calculate it. All right, that's it. Good luck.